All right, this video is entitled Exploring Geometric Mean. Our objective from this is I can apply geometric mean to scenarios that involve 1, 2, 3, or 4 missing terms in a geometric sequence. All right. Now, geometric mean very simply is defined as the square root of two numbers multiplied together. So in its most basic form, geometric mean is how you find the middle number when you're given two numbers along the side of it that aren't in an arithmetic sequence, that are in a geometric sequence, all right? And here's literally what you're going to do. You're going to take the square root of -3 times -12, which would be the square root of 36, which would be 6, all right? And then here's the one thing that I got to remember, though, is the number that's missing here could be 6. That would be if I had a common ratio. Remember that R value that we talked about for geometric sequences. If the common ratio was equal to 2, well, there would be -6. But if the common ratio was -2, then it would be +6. So wait a minute, this is going to get a little confusing for some of us, but hopefully not. This is how you can find it when you're only missing one term. And my final answer here would be that missing term is either going to be plus or minus 6. I don't have enough information because I don't know what this next term is to be able to determine whether it's a positive or a negative. All right? So that brings us to how do you do it when there's more than one missing term? Very simply, what we're going to do is write the explicit formula and find the common ratio. All right, and I forgot to write a step 2 here, but then it would simply be then apply that common ratio, that R value. All right, and you'll see what I mean here. Okay. Because this is a geometric sequence, I know that it involves the formula a sub n is equal to a sub 1 times r to the n minus 1. And in this scenario, we're trying to find r. I know a sub n is my last term that I know. A sub 1 would be my first term. And n is going to be how many terms there are. Okay, so what are we going to do? Well, let's start off by writing down the formula. I know that a sub n, or 32 in this case, is equal to 4 times r, that's what we're trying to find, to the n minus 1. Now there are 1, 2, 3, 4 terms here, so it'd be r to the 4th, minus 1. All right? Now to solve this, I'm going to divide by 4. So that gives me 8 is equal to r cubed. And then take the cube root or raise 8 to the 1/3 power. And I would get an r value of 2. Now because it was an odd root, I know that this has to be 2. It can't be plus or minus 2. That tells me that my missing terms would be 4 times 2 or 8. 8 times 2 or 16, and then I can double check it. 16 times 2 does give me 32. There's my missing terms. All right, let's take a look at this. I'm missing 3 terms here. I'm not worried about it. All right, I know that the last term, -625, is equal to the first term, -1, times r to the, let's see, 1, 2, 3, 4, 5 positions to the 5 minus 1 power. Divide by that a sub 1. So this would give me 625 is equal to r to the 4th. All right. I have to take an even indexed root here. So let me see. I'm going to take 625. And remember, you guys can use the caret symbol. I have to hit this. And then I know I want to take the 1/4 power, or the 4th root of 625. 1 divided by 4, close that off, equals. And I know I get an r value of 5. But because it was an even indexed root, remember we have to demonstrate positive and negative representation. So it could be 5, but it could be -5. I actually don't know here. Well, here's what I can tell you though. I know that to go from -1, I'm either going to end up with a next term of 5 or -5. So I'm going to write plus or minus 5. I know the R value is 5, right? So I'm either going to go from 5, I'm going to go to 25. This has to be a positive 25. A positive times a positive times a negative. The only sign change can occur here and here so that the last term ends up being negative. All right? Is that right, or am I thinking about it wrong? What do you guys think? Let's see. If that's positive, that's negative, then that's positive, that's negative. That works. Or they're all negative. That works too. All right? The third term, if the second term is plus or minus 5, third term is 25, I know that the third term, or the fourth term, the third missing term, I meant to say, would be plus or minus 125. All right? Take a minute and think about that a little bit, and hopefully it'll clear it up for you. The only time you have to worry about this is when you have an odd number of missing terms, or an odd number of terms in the sequence. Okay? Let's take a look at one more here. All right? I'm going to use my formula that says -96 is equal to a sub 1, which is -3, times r to the, let's see, there's 6 terms here. So 6 minus 1 power. All right? If I take -96 divided by 3, -3, I get 32 is equal to r to the 5th. And then again, I'm going to go 32, and I'm going to raise that to the power of 1/5, which is the same as taking the 5th root, and I get 2. So I have an R value here of 2. It has to be 2 because there was an odd index. All right? So my missing terms here would be -6, -12, -24, and -48. And then if I looked, yeah, times 2, that gives me -96. Those are the missing terms. Hope this helps. Let me know if you have any questions.